Hello, welcome. Thanks for watching. In this video, I'm going to go over free radical substitution. I was sensing in class today that maybe there's still some questions about this. Make sure, as always, you're keeping up with questions in the homework doc and in the chat during class, and we'll go from there. Okay, so free radical substitution. Free radical substitution, this is the only mechanism that you need to know for high level. HL people, we will be going over lots of different mechanisms, but this is the only mechanism all of us need to know. As a reminder, an organic mechanism is how a reaction actually occurs, meaning how the electrons are moving. All right, so how the reaction actually occurs, how the electrons are moving. Free radical substitution. This is one of our alkane reactions. So the big picture of this reaction is that an alkane plus a halogen yields a halogen alkane plus H with whatever halogen attached. Remembering that halogens are the elements in group 17 of the periodic table. There's two alkanes that you need to be able to produce this mechanism for, methane and ethane. So let's do ethane. So I'm going to draw the full structural formula here for ethane plus a halogen. Let's use bromine, for example. All of the halogens are what's called diatomic, so they all exist in molecules with two of the same atoms. So the big picture of this reaction is that we would produce the halogen alkane, so we'd produce bromoethane. Let's put a bromine on there. Fill in everything else with hydrogens, plus H with the halogen. So in this case, H with Br. All right. So I have ethane plus bromine yields bromoethane plus HBr. So this is the big picture of the reaction. The conditions, of course, are UV light. Let's look at the steps, the mechanism, and this you do need to be able to produce yourself. So the first step of the mechanism is initiation. We saw today in class, you do actually need to label these steps. So we have here initiation. Initiation just deals with the halogen, so I'm just going to deal with the bromine. And in initiation, the bromine splits up using UV light to form two bromine radicals. The bromine splits up in UV light to form two bromine radicals. This is called homolytic fission because each atom took one electron within this bond. The bond had two electrons. The bond split up. One electron from the bond went to each atom. You are responsible for the word homolytic fission. Homolytic fission means we break up a bond and one electron goes to one atom, one electron goes to the other atom. All right, so initiation, we end up with two bromine free radicals. We now get propagation, excuse me, I think I spelled that wrong, propagation. Don't worry, no points for spelling on the IB. So there's two steps to propagation. We're going to start with that free radical that we just formed in initiation, and it's going to be able to react with my alkane. In this case, I have ethane. All right, I'm going to show these arrows because many of you will need to be able to deal with arrows. You noticed today that the IB did not actually expect you to show the reaction mechanism arrows for free radical substitution. But what's happening here is that the hydrogen cleaves off again in homolytic fission from ethane and combines with Br to form HBr. Remember, HBr was one of our products. So we actually start forming products right here in propagation. What's left? Well, what's left is everything else in this ethane And since we did homolytic fission, we actually have a free radical. So we have an ethyl radical, So missing one hydrogen, it left via homolytic fission, and I have a radical, or free radical. You can say either. All right, now this free radicals are super reactive, so they're immediately going to want to do some kind of reaction. So this free radical here is going to react. Let's draw this out. This free radical is going to react with more bromine. So some of the bromine was involved here in initiation, but I still have some reactant left over. Not all of my bromine molecules were hit by UV light in exactly the right way to do initiation. So I still have some bromine here. And again, homolytic fission. I'm going to cleave the bromine and attach it to my ethyl radical. Well, that's good. That's good news. I just formed the other product that I was expecting. Remember back from the beginning, I just formed the other product I was expecting. What else do I have left? Well, I have a bromine-free radical. So now that I have a bromine-free radical, I can actually restart this process, not with the bromine from initiation, but with the bromine produced in propagation. So this process can continue again and again as a cycle. All right, eventually you're going to run out of energy that the UV light provided. When you run out of energy, you're going to do termination. In termination, you're just basically mopping up any free radicals, getting rid of any free radicals because free radicals are super reactive. They can't just hang out. So I had two free radicals that would be formed in propagation. So within my reaction mixture, I'll have two different free radicals floating around. These guys. And these guys are going to have to combine. So I could have two ethyl radicals combined. Ethyl radical plus another ethyl radical. Lots of drawing here. These guys could combine. What would I form there? I would form butane. I have 1, 2, 3, 4 carbons, unsaturated. Butane, or some sort of alkane, is always going to be a waste product of free radical substitution. It's not a very efficient process because you do get a lot of waste products. One Br and another Br can combine to form Br2, which was actually one of our reactants. So in termination, we end up forming a reactant all over again. And then the other option is my Br radical could combine with my ethyl radical. Here we go. To yield bromoethane. Sorry if I said that weird. Which this step actually gives us a little bit more product that we were expecting. All right, I hope that helps. Make sure you are being proactive about asking lots of questions, and I'll talk to you soon. Add any questions you have to the homework document. All right, bye.